be writing JAMB this year. Listen to me carefully. I'm going to tell you something very serious. First of all, last year, the students I coached, 5 of them scored 300 and above. 11 of them got 250 to 299 within that range. About 26 got between 200 to 249. And 21 got 150 to 249. Then I have 26 rather, so I have 21 score between 150 and 199. And I have 2 scored less than 150. Now, what I want you to see in this is that I'm proud of the achievement of my students. I'm proud they listen to me. I'm proud they learn with me. I'm proud they listen to all the advice I gave them, and I'm proud with their results. And my goal is to have more score above this in this year's JAMB. Now, if you are one of those serious students who is looking for someone that will guide you through the process to pass your JAMB excellently well, then you are at the right place. First of all, I deal with serious students only. I know if you are watching this and you are my student already, I'm showing you this to remind you that you are at the right place, provided that you would complete the simple tasks and watch all the videos that I've been posting, which contain a lot of messages. There is no reason why you should fail JAMB this year. There is no reason why you should not get your target score. But if you are not ready, if you are lazy and wouldn't want to take any responsibility, you wouldn't want to complete any tasks, you are given assignment, you find it difficult to meet up with the deadline and you come with excuses, then you are not ready to work with me. But if you are ready, I would like you to first of all subscribe to this channel. There are a lot of videos, and I assure you, if you can only go to even the last year only, if you can go through all those videos, your success is guaranteed already, because I knew what is on this channel. So the first thing I would like you to do is to quickly subscribe to this channel. If you want to be part of those I'm mentoring against this year's JAMB, you can drop on the comment section that I'm interested. Don't wait till the end of this video before you drop that. To do that now so that I would see your comment and also link you to the rest of my students. There is no time again. We are getting closer to the D-Day. So this video is a continuation of the organic chemistry video that I have made previously. Remember, I have a strategy. I have an approach to my own JAMB lessons. I don't just go anyhow. Many concentrate on just past questions, but that alone is not sufficient. I have told you my strategy of reverse engineering approach that I have adopted, which have worked for me while in the university, which has helped me to graduate as a first-class student, which has helped me during my master's program, and which I have advised many students to adopt, and it worked for them. In fact, even this course that you are seeing, it was the same thing that I have suggested for them, and those that implemented it also saw results. So it's something that works every day. What is this strategy? Is that I go to JAMB syllabus, I look at the objectives, and I see JAMB say students are expected to know this, be able to do this. That are your questions already. So just change those things to questions, and that's all. You are already preparing yourself very well. So relying on past questions alone is not adequate. That's why I adopt the strategy of following JAMB syllabus gradually. If you are my student, you know that this is not the first video. So this is the continuation of the videos in organic chemistry. And I decided to continue from where I saw, because I want us to cover it exhaustively. You remembered in one of my videos where I told you that in organic chemistry alone, you may have like 15, 16, and even up to 20 questions. What that means is that if you ground yourself and master this topic very, very well, it means that you have a chances of scoring even more than half of the scores under chemistry. I have shown you how JAMB asks a lot of questions under organic chemistry. In fact, if you remember in one of the videos I have posted on how to prepare adequately for JAMB, you would remember I've talked about some topics being key topics which you should concentrate more on. Why are they key? Because a lot of JAMB questions come from these key topics, unlike others where JAMB will only pick one question and ask on that topic and two. So I am very strategic and I'm out here to help students. My goal is to see that whoever is serious gets a proper guide to their achievement. I'm proud of my academic achievements today, and it pains me when I see students out there who are serious but they lack guidance. And that's why I came on this platform to see how I guide students. I've started last year and I'm continuing this year. So quickly, without wasting much of our time, let me just quickly run us through the completion of the organic chemistry which I have started in the previous video. If you are new here, please just subscribe to this channel. You don't have any other channel that is giving you tips, that is giving you strategies that works, proven than this. So I would like you to subscribe, like, and drop a comment that you are interested in joining my class so that I will find a way to join you. So this is the continuation, and let's dive right into it to see what we have. So we are looking at physical properties. Remember, all that I'm treating here is JAMB syllabus, nothing but JAMB syllabus. I'm highlighting the likely questions you are to expect in this year's JAMB. So JAMB said that you are expected to know the physical properties in relation to homologous series. In the last video, I talked about homologous series. I talked about groups of carbons, carbon compounds that differ with maybe a carbon and two hydrogens. So this is the continuation, and I would like you to pay attention. Please, if you are busy, just close this video, just pause it and go and finish what you are doing. When you have time, come and listen to it. If you cannot watch it now, just know that you are not yet serious for it. So keep your phone, pause it and go and attend to what you need to attend to. Otherwise, I would like you to avoid any form of distraction, because we are answering your questions already in this video by taking every key detail and every key step into consideration based on JAMB syllabus. All right, so let's go. So what happens to boiling point as the number of carbon chains increases? So the boiling point increases as the chain increases. For example, we know methane has 1 carbon, ethane has 2 carbon, propane has 3 carbon, butane has 4 carbons. So if you are given these 4 different compounds, which one do you think will have higher boiling point? Of course, the one with the higher number of carbons. So boiling point increases as the number of carbon increases. Then in branched chains, okay, I'm sorry, let me say this. I would share this PowerPoint with as many of you that are interested after this class, so you can chat me privately. For my students who are on my WhatsApp group, just chat me privately. I would share it so that if in case you are not seeing clearly or you want to revise it again, I will make it available to you. If you are not my student but still want it, you can also indicate your interest in the comment section, and I will find a way to get it across to you either through email or through WhatsApp. Thank you. So one thing you should not forget is that the more the number of carbons, the higher the boiling point. So I have seen several questions where JAMB will arrange different compounds and say arrange them or rearrange them based on their increasing boiling point. You see, they want to know either you know that the more the number of carbons, the higher the boiling point. So the next key important thing is the branch chains. The branch chains have lower boiling point than straight chains because of the less surface area. So they may sometimes give you the branch chain and the straight chains and ask you to arrange them based on the increasing boiling point or decreasing boiling point, whichever way. So once you know these 2 key principles, that the more the number of carbons in the chain, the higher the boiling point, and the branch chains have lower boiling point compared to straight chains, then you are good to go. You can answer that question. Generally, hydrocarbons are insoluble in water but they are soluble in polar solvents. I will not be able to explain to you what polar solvents are now because it's a little bit advanced, but it's very important that you know it now. There are some compounds we call non-polar solvents and we have what we call polar solvents based on microscopic separation of charges. For example, water is H2O, it has oxygen, so water is a polar compound because it has a portion that is more electronegative and another portion that is more electropositive. I don't want to go deep into that, but just know that hydrocarbons are insoluble in water, but they are soluble in non-polar solvents because it may be tested whether you know their solubility. So density increases with chain length, but the density of hydrocarbons are less than water. So the more the chain length, the more the density. So as it relates to structure, the longer the structure, the higher the boiling point. So this is objective 4 in the JAMB syllabus. They say you should be able to. So, and these are the things that I've listed already. I wouldn't want to waste much time. Let's go to the next. So this is a graphical representation. I know JAMB very well. They want to also assess your ability to interpret. Yes. Structures, images, different illustrations. So if you look at this don't be surprised to see this kind of thing in JAMB this year. I'm telling you, don't be shocked. So you should know this. So this is homologous series. I told you that homologous series just explains the difference, how the difference affects the properties of hydrocarbons. So between ethane and methane, there is a difference. The difference is just CH2. So that difference in one carbon and two hydrogens alone affects or makes the physical properties of one compound differ from the other. So here we see the boiling point, yellow in color, boiling point versus carbon number of atoms. So you can see that on the vertical we have the boiling point in Kelvin. On the horizontal we have the number of carbon atoms. So you can see that as the number of carbon atom increases, the boiling point also increases. So also we have for linear alkanes, which is red in color. We have for halogenated, which is green in color, and so on and so forth. So when I share this slide, the goal is for you to know that the more the number of carbons, the higher the boiling point. So yeah, JAMB will test your knowledge about the reactions of hydrocarbons. Hydrocarbons undergo specific reactions. For example, alkanes undergo substitution. Alkanes are saturated, so they don't undergo addition reaction, but they undergo substitution. Whatever is coming, such as halogens like chlorine, fluorine, they can substitute a hydrogen to form a haloalkane, but they do not undergo substitution. On the contrary, the alkenes and alkynes, which are unsaturated, can add to themselves, so they can undergo, the double bond can break so that it could add to it. So never forget that alkanes undergo substitution. Please, if you need to get a paper and pen to write this, I beg you, it's for your own good. I would also be happy if I hear your testimony that you score 300 and above. So if you need to write something, just pause, get your pen, get your paper, and write them down. Thank you. So let's go. So we have the kind of reaction that these alkanes undergo, we say is substitution reaction. And this substitution reaction proceeds or happens in the presence of light. So which we call free radical mechanism. You don't need to do that much, but it's important. Just know the basics. So we have an example. Now, something happens here. I'm using my phone to record. So when it was on laptop, this apostrophe N, under this example, you are seeing it there between the two compounds, is an arrow. So, but it's showing apostrophe N when I open the document on phone. So don't be confused. That N stands as an arrow in that position. So we can see methane plus chlorine gives us chloromethane and hydrochloric acid as the end product. So that's the substitution reaction. So what are the properties? What are the properties of alkanes? Alkanes are usually inert. They are not reactive, except with halogens in the presence of light. So usually they are inert, they are not reactive because they are saturated. So related to structure, we have saturated, so substitution, not addition. So alkanes are saturated, so they undergo only substitution reaction, not addition. I've said this earlier. So we have the halogenated products and their uses. Every year, almost every year, JAMB asks question on these haloalkanes. I don't know why they are interested in them. Some of these haloalkanes are used in detergent industry. Some of them are even used as drugs. Some of them are used as anesthetics. Some of them are used as insecticides. They are diverse. So you need to know, you need to have a background knowledge because a question is coming out of there and you will come back to tell me that you have answered a question under halogenated products or haloalkanes. So we have chloromethane, we have dichloromethane, we have chloroform, and we have carbon tetra. So all these are examples of halogenated products. Sometimes it may not be chlorine that is there, it may be iodine, it may be fluorine, but it just has to be a halogen. You remember group 7 elements, they are halogens, right? Yes. Chlorine, fluorine, iodine, astatine, bromine, and so on. So all these are group 7 members and they are called halogens. So when they react with alkenes, they form haloalkanes. And these are the products we are talking about. So what are their uses? They are used as solvents, they are used as refrigerants, they are used as pesticides, and so on and so forth. So I've given these examples. So what are the properties of haloalkanes? They are volatile, they escape in air, they are non-flammable, they don't catch fire. Toxicity increase more with halogens. For example, chloromethane with only one chlorine is not as toxic as dichloromethane. So the more the number of halogens attached to a hydrocarbon, the more the toxic it becomes. So this talks about objective 9, objective 4, that is linking the properties of haloalkanes with their uses. So I hope this is clear too. We continue. Then we talk about isomerism, and you would also see a question here. So in one of the objectives, JAMB said you should be able to know what isomerism is, and you should be able to give examples of isomerisms and types also. So what is isomerism? Generally, you should see it or you should know it because they may say two different compounds having the same molecular formula but different structural formula are referred to as. They will give you options. That's how they ask. So they won't ask you define isomerism because you are not allowed to write. You just select the right answer. So please know that isomers have the same molecular formula but different structural formula. If you want to write their condensed formula, they are the same. But if you want to write structural formula, they are different. So I believe that to many of us, this is just a revision. But if what I'm saying is abstract and like you are not understanding what I'm doing at all, then you need to chat me privately because we need to talk basics before you understand what I'm trying to say. So we have types of isomerism. We have structural isomerism like chains, different carbon skeleton, no stereoisomerism in simple alkanes. So simple alkanes doesn't have stereoisomerism, no chiral centers unless branched. So chiral centers, a carbon that has 4 different groups attached to it. So then we have derived isomers from a formula. So you may be given a formula and they will ask you what are the number of possible isomers we can get from this compound. Just be patient with me. I'm working on getting a board so that I will be able to give a better explanation about this. For this now, I should have given an example where I write on the board. Meanwhile, for now, I don't have it, but I'm working on getting it, and God willing, I will have it soon, and the explanation will be more better and more detailed. So look at this derived isomer. You say deriving isomers from a formula is an objective already. Also, JAMB expects you to know it. So we have C for H10. So what are the possible isomers you can derive from them? So first of all, that alone on its own is butane, but then it can be rearranged to form methyl propane if the CH2 is at the middle of the 3 carbons. I just hope this is clear. Please, I will take time to revise this again once my board is with me. Thank you for understanding. So you should be able to distinguish between chain and positional isomerism. I need to also make, oh, so sorry for the interruption. I sincerely apologize for that interruption. I forgot to put my phone on flight mode, so calls were coming in. So sorry. So let's continue. Okay, so I've given an example of positional isomerism here. Now look at this carefully. Look at the position of OH is at the end. So this is referred to as 1-propanol or N-propanol, that is normal propanol. I have made a video on naming organic compounds. Please, if you have not watched it, go and search through the channels. If you can't find it, just come back to the comment section and see right, and I will trace it and share the link with you if you don't know how to name organic compounds. So based on our counting now, this first carbon will be 1, and then we count from right to left because we give the functional group the lowest number possible. So that's normal propanol. Now look at on the second compound, the hydroxylic group has been changed. The position has been changed to carbon number 2. Do you see that the name has changed already? And so we call these compounds isomers because if you are writing their molecular formula, it will be the same. But if you are writing their structural formulas, it's different. So they are isomers. So when the OH is shifted to carbon number 2, it becomes 2-propanol or propan-2-ol. The first one can be 1-propanol or propan-1-ol to mention the position where the ol is. That's anytime you hear ol, alcohol, okay. So this is also another example of structural isomerism. Different ways carbon can be arranged for CH5, for C5H12. So we can have normal pentane, 2-methylbutane, 2,2-dimethylpropane. So all these are examples of structural isomerism. Don't forget, this one is positional, the position of the functional group. Meanwhile, this one is structural because JAMB says you should be able to differentiate between structural and positional. So this is structural. The whole thing, arrangement of the carbons has been changed. While in the positional, the position of the functional group has been changed. I hope this is clear. There is room to ask questions, please, in the comment section. Feel free and I would attend to them. So these are examples of structural isomers. And I won't take much time here. So properties differ. You should know that because JAMB also wants you to know how isomerism affects properties. So branch isomers have lower boiling point compared to straight chain isomers. You can also write this. So we have classification of hydrocarbons, aliphatics, and aromatics. I believe that all these are very simple to us. Know the formula, please. Formula for aliphatics, which are alkanes, alkynes, and alkenes. Please know these formulas. They have appeared again and again in JAMB. They would say the general formula for alkynes is, they will just give randomly wrong ones with the correct one. Please be able to identify them. Now, just get your sheet of paper, write for alkanes, write for alkynes, and write for alkenes, and memorize them. Very important. Then, distinguishing their properties, we have alkanes to be inert. I've already mentioned earlier that alkanes are less reactive or non-reactive compared to alkenes and alkynes, which are reactive and they undergo addition reaction. Lastly, alkanes are generally used as fuels. Yes. While alkenes for plastics. In one of the assignments I gave for my students, I remembered we talked about, either one of you came to my DM and was asking, or it was in the group, I think, that alkanes may also be used as for plastics, because that was also an option. And we were answering a JAMB question. So please never forget this. Anytime we talk about alkanes, they are used as fuels. We are going to see more of it in, I have shown a hair. So under this crude oil, JAMB also expects you, so expect question. In fact, many questions under crude oil. I have seen them again and again, and so expect question here. I won't talk much about crude oil. I believe you know what crude oils is. It is a complex mixture of hydrocarbons. Alkanes are there, alkenes are there, aromatics are there. So composition, 50 to 98% are hydrocarbons. Sulfur is there, nitrogen compounds are also there. So crude oil is not uniform. Each country have their own. For example, the quality also differs. For example, in Nigeria, we have Bonny Light. I think Nigeria is also the one that produce Brent. You will see different types, different grades. So the Nigeria produce one of the quality crude oil is rich than some other countries. I think is it Korea or Asia? One of the countries also produce one of the best in the world. So the crude oil are not the same. Please know this. Importance of crude oil, source of fuel and petrochemicals. So fractional distillation of petroleum, you should know this. I don't know if the image is very clear for you to see, but we have a diagram of how crude oil or petroleum, anyone, they are the same thing, is extracted into different fractions based on temperature. So I won't explain this much. I believe some of you are familiar with this, but if you need clarity, I will say explain. What this tells us is that when the crude oil is heated at different temperatures, everyone evaporates. Remember our separation techniques? So the lesser molecules, first of all, escape from the crude. For example, our cooking gas, methane, ethane, and low carbon compounds, they escape within the temperature of less than 25 degrees. While if you heat further to a temperature of between 25 degrees to 60 degrees, you have gasoline, which we call petrol. And continuously you have naphtha, paraffin, which is usually called kerosene, used for ships. When I share the slide, please, you would see the images clearly and get more. So what's the process? The process is to heat the crude oil, vaporize it, then cool in the towers. The fraction condense at different heights based on the boiling point. This is very important now. Major products. Gases are those with carbon 1 to 4. Between 1 to 4 carbons. Petrol, 5 to 8 carbons. Kerosene, 9 to 16 carbons. Diesel, 14 to 20 carbons. And lubricant, greater than 20 carbons. Then after that, we have bitumen. So you should know that petrol is between 5 to 8 carbons. Just know the popular ones. Okay. So we have related fractions to properties. Short chains have lower boiling point and they are more volatile. Of course, that's why gas, which is between 1 to 4 carbons, evaporates first as temperature less than 25 degrees. So you should know their uses. We have petrol for cars, kerosene for jets, etc. Yeah, this is very important and many of you don't know it. Do you know that diesel can be changed to petrol? Do you know that? Do you know that bitumen, the one they call coal tar, this black that they use to tar the road, do you know that it can also be converted to petrol? It is in the process of cracking that these things are done. So what happens during cracking? During cracking, long chain alkanes are broken into shorter ones using thermal or catalytic process. So remember, look at this again. We said petrol is between 5 and 8. Kerosene is between 9 and 16. Now, if you have a 16 carbon compound and you break it into 2, you have 8 carbon compounds and that becomes petrol. So if it is 16, that's diesel. If you break it into 2 to make 8, that's 2. You have your petrol. So this is what is called cracking, where you break long chain compounds to shorter chains to get a different product. So we have thermal cracking using heat. We have catalytic cracking using chemicals as a catalyst. So you can produce more petrol fraction if you want. Let's say you have 1 drum of crude oil after extraction. Over half of it is maybe diesel, and you want more of petrol because petrol is consumed more than diesel. So what do? You can take that half drum of diesel and change it into petrol through cracking process. Okay, so let's go. Okay, so this is just a diagram for cracking. You don't need to know that much. So we have quality of petrol, petrochemicals. You are supposed to know this too. So there's what we call octane number, very important. So it is by this octane number that you measure whether the petrol is of higher quality. So between the scale of 0 to 100, we have iso-octane. Then we have the higher the iso-octane, the higher the better the performance of the petrol. So we have a scale of 0 to 100. So if you have high octane number, high percentage of octane number, that's those with 8 carbon chains that are 8. Because we said, remember, for petrol, we gave a range. We say between 5 and 8. So carbon number 6 is also under petrol. Number 7 is also under petrol. Number 8 is also under petrol. So also number 5. So if you have more of carbons, 8 carbons, then your petrol will be better. So if a petrol has less octane number, it can be improved through additives and reforming. Reforming is the process of improving the quality by increasing the octane number. So we have isooctane. This is actually the real petrol, 2,2,4-trimethyl pentane. This has carbon number 4 carbons. Remember, pentane is 5, then 2,2-trimethyl, that's 3 carbons. So, and it assigned a value of 100. So it is highly branched and resists knocking extremely well. So, but N-heptane, normal heptane, which is carbon number 7, is assigned the value of 0. It is a straight chain alkane that knocks very easily. So it knocks, that is when the petrol mixes with air in a combustion engine, it catches fire prematurely. Okay, so thank you very much once again for listening. We have come to the end, and I have assignment questions for you under this category, JAMB 2010. I have a question here, JAMB 2010, ethylene. Okay, I just picked JAMB 2010 questions. So I have 3 good questions for you as assignment. All of them are very simple. If you have listened to me, you will be able to have an insight on how to answer them. And these are the kind of questions you should expect to see in JAMB. Why I give assignments is to keep you engaged, to make what you have learned retain or stay, to solidify it. So please, I beg you, do this assignment and submit. Some of you, my students, you have the habit of not completing your own tasks. I don't know why. And you are doing yourself. This is what affected a lot of students last year. They were just in the group, but they are inactive. You give assignment, they don't do. You call for mental drills, they don't show. You drop WhatsApp tests, they don't. Whatever you do, they will not do. They are just there. So I had to introduce house cleaning last year to remove all those that are not active. So please, I beg you, submit this assignment. Know that I have the record of all of you that have been showing up and completing their own tasks. So please complete this and send to me, to my DM. If you are not in the group and you are interested, please drop in the comment section that you are interested in the group, in joining my group. If you are my student, you have watched this to the end, or even if you are not my student, if you have watched this to the end, okay, I salute you, and I will tell you why. There are many starters, but there are few finishers, and people who are not patient enough to sit, they won't learn anything. That's just the truth. They are fast, they want to touch a little, before you know it, they have gone. They are distracted people. So if you have watched this video to this end, I want to particularly greet you, and I would like you to drop it in the comment section that I have watched the video to the end. I want to see people who have watched it to this end and those who have not watched it. Thank you very much. See you in the next class. Please hit the notification button so that anytime I drop a new video, you will be among those that will first know and come and watch it, finish your tasks on time, and stay up to date. Once again, if you have watched to the end, don't forget, please drop I have watched this video till the end, Mr. Emmanuel. Thank you very much. Bye.